Okay, so this is the second video of the continuation of the first part of the video. In the last video, I've talked about those threads and the processes. Now I wanted to, tell more stuff. So I've made this video as well. It's the continuation. So yeah, you can enjoy it. Okay, so things I need to explain that to solve the, the utilization problem of multiple threading, using multiple threads, multiple cores, sorry, using multiple cores. There are 4 to 5 ways. Okay, maybe four. I do not recall that as we discussed that we get to know that there are 4 or 5. But yeah, there are ways to utilize these cores, and certain applications, certain servers do that. So the first, which is that for each core, uh, we have one listener server. Okay, because for one port, by default we can spin up one web server, and that server will accept the request and distribute to the cores. So for one request there is one new thread, and which can be processed parallel by the CPU in the thread. So one listener thread and multiple request handler cores or threads. So that is used by many servers. They utilize these cores by what by just passing that request after connection is done for the TCP. Those requests are just forward to process by the threads, and for each request we spin up a new thread, and that, as you can see, that could be a problem because every thread will have their own memory maybe, and that maybe context, and that context needs to be switched every time a CPU needs to handle one of the thread. Also, there is a limit of threads we can spin up. Even if we have 4 cores, we can spin up more than 4 threads, but still we got to have a limit. So eventually we got some better utilization of core, but eventually we will hit again to that managing thing, and we got issues of the main core problem is the overloading of threads, because we do not maintain you know any way to check whether any thread or any core or any pool of threads are doing heavy lifting, while other request handling threads are doing not so much, because they have the connection and connection is not doing such much and they are resting. So to solve that problem, there is a second approach, which is our listener will hold all those requests and will do the thread management itself by checking each thread, whatever the what if it is has a less load or the more load, and that management of the request it will do. Earlier it was passing on any request and spin up the thread, passing the request, getting the request, and doing just a distribution, simple distribution, without knowing like which thread is free or not, which thread is already in use or not, or heavy under use. Also, apart from that, it needs to read all those requests, because to know which request is heavy and which core or which thread can handle it better, it needs to do the read part. So our listener thread will do all more heavy lifting, which can affect the throughput, because it will need to stay somewhere sometime for the listener before going to the main parts to be done. But yeah, overall it's looking like a better approach. The third approach is to reuse the same port and maximize the listener thread, because as in the previous solution you have seen that the listener thread is one. So, and we are also giving it more responsibility to do the management stuff and all. So essentially our throughput is bottlenecking, since we are only using one listener thread. Listener thread is simply which where first our request will go after the CPU and TCP handshake. So and we cannot spin up multiple listeners, because the same thread, as we got that error, the port is already used. for one pod is restricted to use only one listening process or listening thread. So there is a configuration in servers that which enables us to use same port for multiple listener thread. So what essentially now against the problem of load balancing is come, or the distribution is come, because if that port is the main entry point for the servers to give the request to the user, then it will simply push up those requests to that's one single listener, and then now there are multiple. So CPU needs to decide like which ports which listener we it need to distribute, and it can be anyway, but it will increase the throughput because there are more listeners can handle a bunch of requests. Now the fourth and the last part was have a single listener, because to avoid the complexity, or maybe multiple listener, but to avoid that thread management thing, for each internal port, or if it is not supporting same port, we use for spin up many single threaded efficient application to the multiple threads, same application, not spinning up the new thread for us for singular whole application. It's deployed on many places in the same server on different ports, and that the that our CPU will do the job of distributing the request among those servers, sub servers in the one server, and or it can reuse the same port, so it will do the job very efficiently. Otherwise, we need to have an IP mapping table. So, for all 443 requests, we can map to this pool of multiple ports where these sub-servers are living, and this can be distributed. This is the fourth thing which can be helpful and which is also being used in the production. So yeah, that's it for this video. I will try to make more videos and more quality videos. So I'm waiting for comments, any comments or any new questions or any suggestions. Okay, thanks for watching.